Hi everyone. So today we're going to work on solving radical equations. So by the end of today we're going to be able to solve them, which means we're going to be looking just like our regular solving techniques for the value that's under the radical. Okay, so what exactly is a radical equation? Well, this is going to be an equation in which the variable is in the radicand. Okay, and what I mean by that is under the radical. Okay. For example, the square root of 2x equaling 12 is a radical equation. The cube root of x minus 2 is equal to 16 is a radical equation. But x times the square root of 2 equals 4 is not. Okay, because the variable is not underneath the radical sign. Okay, so the first two are, but the second last one is not. So let's have some steps to help us solve this. Okay, so our first step is to isolate the radical. Okay, isolate the radical. Get the radical by itself. So get rid of what's being added, subtracted, or multiplied and divided. So if I'm looking at this particular equation, the square root of 3x plus 3 equals 12, I'm going to subtract the 3 from both sides. So we get the square root of 3x is equal to 9. Okay, so our next step would be to raise or square cube to the fourth both sides of the equation. You can't just do one, you got to do both. Okay, so remember what's happening on one side of the equation has to happen on the other. So we're, in this case, squaring both sides because we're dealing with the square root. If we were cubing, if it was a cube root, we'd cube both sides. If it was a fourth root, we would take it to the fourth. Okay, so we're going to, I want to say raise both sides of the equation to the appropriate power. Okay, so let's say raise both sides of the equation. Let's just go to the power. So here, we're going to raise this to the squared because it's a square root. Now when you square a square root, they cancel each other out. So we get 3x is equal to 9 squared is 81. Okay, so we're going to solve. In this case, I'm going to divide by 3. We get x is equal to 27. All right, so I know it's a lot of times we don't do this step, but we definitely need to check our solution. And you can't have more than one solution, by the way. So let's put a pretend S there. Because this may be the solution to 3x equals 81, but may not be a solution to the original problem of square root of 3x plus 3 equals 12. Okay, so I'm going to do my check over here. We always go back to the original equation. And see if we're right. So 3 times 27 is 81. Okay, the square root of 81 is 9. And 9 plus 3 is 12. So both sides are equal to 12. We are good to go, and that this is our solution to the square root of 3x plus 3 equals 12. All right, so let's try a couple of these. Oh, before we do that, we need to talk about extraneous solutions. Extraneous solutions would be if 27 didn't work, but it was still an answer to the problem. So an extraneous solution is a solution to an equivalent equation that is not a solution to the original problem. So let's write that. Solution to the problem, a solution to the equation, to the equivalent equation, but not, excuse me, what happened there? There we go. But not to the original problem. So we're always looking to make sure that we don't have extraneous solutions. Because if we do, that means it's not a solution to the problem. And we may end up doing all this work and our solution is that there is no solution. So that would be really annoying. Okay, so let's try a couple of these. All right, so we're going to solve the radical equation and we're going to check our answer to see if it's an extraneous solutions. So the first thing we're going to do here, we want to isolate the radical, so I'm going to subtract the 2. So we get the square root of x is equal to 10. And because it's a square root, I'm going to square both sides. So x equals 100. Not too bad. Now we're going to check our answer. So we're going to go to the square root of 100 plus 2. The question is, does this equal 12? Like, I want to know, is that true or not? So the square root of 100 is 10. 10 plus 2 is 12. So we get 12 equals 12. Cha-ching, that's true. Therefore, 100 is our solution. Let's try another one. Okay, so we have the cube root here. So there's nothing added or subtracted, multiplied, or divided with the radical, so I'm just going to cube both sides. Okay. So we're going to get 2x minus 4 is equal to 8. Solve for x. Now what I just created was the equivalent equation. 2x minus 4 equals 8 is equivalent to the cube root of 2x minus 4 equals negative 2. Okay, so I'm going to add the 4, divide by 2, and I got 6. So the question is 6 the solution to that cube root? Okay, so the cube root, 2 times 6 minus 4 is equal to negative 2. So that's our question. So the cube root of 12 minus 4, cube root of 8, the cube root of 8 is 2. Well, that's not the same as negative 2. So that means our answer of 6 is not correct, which means this, an extraneous solution. 6 would be an extraneous solution, and we would write our answer that there is no solution. Okay, that's why it's so important in these problems to do the check. Okay, you really do need to do the check here. All right, let's try another one. And then I'm going to ask you guys to do a couple. All right, so here we have 2 equal radicals. So then they're both of the same root, square roots. Okay, so if they're not of the same root, then we have to do something completely different. We're not going to go there right now. So we're going to square both sides. Okay, square both sides. Okay, so we're just going to get 7x equals 8x minus 1. Solve for x, let's subtract 8x, so that's going to give me negative x equals negative 1. X equals 1. Again, we do need to check, especially when we have variables on both sides. Like we got to double check that. So we get the square root of 7 times 1 is equal to the square root of 8 times 1 minus 1. Okay, so 7 times 1 is 7, so we get the square root of 7. 8 times 1 is 8 minus 1, which is 7. So the two sides are exactly the same. They're both equal to the square root of 7. So that means 1 is our solution to this problem. Okay, let's try one more. Okay, so we're going to add, we have to isolate the radical, but we have two of them. So we're going to put one on one side and one on the other. So we're going to need to add the square root of 2x plus 7 to the other side. We're going to square both sides because they're both, so now we basically do what we just did in the previous problem. Okay, so we get 3x plus 7 equals 2x plus 7. So we get x equals 0. All right. So let's check our answer. So square root of 3 times 0 plus 2 minus the square root of 2 times 0 plus 7, is that equal to 0? Well, this is the square root of 2 minus the square root of 7. I don't think that's equal to 0. Okay, so that is definitely not equal to 0. So this would be no solution. We get a lot of these no solutions. Now, again, that doesn't mean you just write no solution, guys. You do need to show all your work and why it's not a no solution. All right, so why don't we try 2, 4, and 6? Okay, or 2, 4, and 8. I don't know why there's no 6. Pause the video, try 2, 4, and 8. All right, let's check it out. So in the first one, we had to subtract the 2. And I get 46 out of 4. That's okay. I put in the check and I end up with 9 equals negative 5. Not even close. So therefore, no solution. I didn't write no solution here. Okay. It just so happens I did it again. And I got no solution. Let's try one. Oh, I think this one works. Yay. All right, we are going to have the challenge question where we're going to end up with a quadratic that we're going to factor. These should all be factorable. Okay, so I get 6 and 7, and you're going to need to check both solutions. So when I put 6 in, I got it to work, and when I put 7 in, I got it to work. So here's a case where both solutions work. Okay. And we're not going to do 10. All right. Let me know if you have any questions, guys. That's it. That's all there is to it. So isolate your radical, solve, okay, square, cube, or to the 4th, whatever you need to, whatever the root is, that's the power you're going to do. Solve. Once you do that, the radical goes away. Solve for your variable. Check your solution. All right, let me know if you have any questions. Stay safe out there, and I'll talk to you again real soon.